Hi guys, hope you're having a great day. Today we're going to look at 3.5, which is sinusoidal functions. Okay, and it's just going to kind of look at the same ideas that we looked at last unit and just kind of, or last lesson, excuse me, and really just kind of expanding on that. So this is on the very first page of your notes. This is all what we said last time. So none of this is new information except this last statement, which I'll talk about in just a second, which is symmetry. But kind of the key points, the domain, the range. I wrote out the amplitude, remember, is the absolute value of A. For a parent function, it's 1. The period is 2 pi over the absolute value of B. In the case of the parent function, it's 2 pi. And then just adding on one additional thing, which is symmetry. So remember we talked about with polynomial functions a lot of times the symmetry being odd or even. So if you were to expand this cosine graph like this, you would see that it's symmetric about the y-axis, meaning pi and negative pi, when x's are opposite, y's are the same. That's an even function. On the contrary, if I look at sine of x, this would be negative pi over 2 right here. When x's are opposite, y's are opposite. So sine of x, at least the parent function, is an odd function. So hopefully you can make that connection to what we talked about earlier this year. Okay. All right, so we're going to kind of just look at a lot of this will be review of finding period of a graph and all that stuff. So period is the distance or how long it takes to complete one full cycle. So a lot of times in word problems, you'll see this as like it completes one full revolution or one cycle is completed every 5 minutes or something like that. That's just the period. That's all they're talking about. So a lot of times you can do max to max or min to min. It's actually a little bit challenging here because my max, the x values aren't labeled. So you can use the x-intercepts. You just have to make sure that it's going in the same direction. In this case, it's increasing and increasing. I don't want to include that point. That's not the period. So in this case, the period is pi. This one I'm going to do max to max, and I see that's pi over 2. If, for example, I had something like this, let's just say, and I decided to go min to min. I know a lot of you guys know this already. But remember, the period is the distance between, so I'd have to do 6 minus 2 to give me 4. Okay, so just be careful if your max or min or whatever point you're using is not at x value of 0 to make sure to subtract them. All right, use the equation to find the period of the function. So remember, we're going to do 2 pi over the absolute value of b. So this one would just be 2 pi over 5. Now, this could really be rewritten as negative sine of 1/3 x. 1/3 is your b value. So 2 pi over 1/3. We're going to think about if I divide by 1/3, that's the same as multiplying by the reciprocal or multiplying by 3 over 1. So 2 pi times 3 would give me 6 pi. Okay. All right, and then amplitude. Okay. Amplitude is the height from the midline to the top. So in this case, that would be 4. It's helpful sometimes to identify what the midline is. So if I think about the total height is 1, 2, 3, 4, 5, 6. So 1, 2, 3, this at y equals 2 would be the midline. So if the total height is 6, then half the height is the amplitude, which is 3. All right, amplitude, remember, is the number in the front of the trig function. It's always positive, so this would be 4, and this would be 1/2. Okay. All right, let's look at midline now. So if you go to the bottom right here, example 6, find the midline of each function. This one I think might be the exact one we just did, and I already told you the midline. So that would be y equals 2. Midline is always a line, so it should always have y equals in front of it. This one I see my top is 2 and my bottom, my minimum is -8. So that's a total distance of 10 units. So to get the midline, I'm just going to count up 5. So that would be y equals -3. Okay. Algebraically, what you could do is if you add the max and the min, so 2 plus -8, and then divide by 2, I would get -6 over 2, which is also -3. So if you want to think about it that way, just be careful. Sometimes people mess up their signs and what's adding and what's subtracting. The midline also corresponds to what's being added or subtracted. So if it's being shifted up or down, and that's just going to be found on the end. Okay, so for example, in part A, I'm shifting down 5. So my midline would be at y equals -5. In part B, I'm shifting up 4, so my midline would be at y equals 4. Again, notice that I put the y equals in the front every time. Okay. All right, let's now look at period and frequency. So 2 kind of distinct vocabulary words here. Period is the length of one full cycle. Frequency is the number of complete cycles the periodic curve completes in 1 unit interval. So it might be like how many cycles it completes in 1 minute or 1 second, depending on how the problem is defined. Okay. So let's go ahead and find the period and frequency, and notice that these are reciprocals of each other. So if I tell you the period, you should be able to pretty easily find the frequency and vice versa. So on this one, the period is 2 pi over b, which 2 pi divided by 1/4 is the same as 2 pi times 4, which is 8 pi. And then the frequency would be the reciprocal of that, or 1/4 divided by 2 pi. And that gives me 1 over 8 pi. Or you could just find this and flip it. All right, so then for this one, same idea. The period, let me label this, is 2 pi over 48 pi. Cancel the pi's, that simplifies to 1 over 24, which then if I just find the reciprocal of this, that would give me 24. We don't really know what units it is without giving context of the problem. So let's do one in context. Example 9, it says it completes 1 cycle. A mass on a spring oscillates back and forth and completes 1 cycle in 0.25 seconds. Its maximum displacement is 6 centimeters. Write an equation that models this motion if the spring is released from the maximum height. Find the frequency of the behavior. So I'm just going to find the frequency. We'll get to the writing the equations or the full equations in the next lesson. But 1 cycle every 0.25 seconds, that is the period. Okay. So that means it does 1 cycle every 0.25 seconds. So the frequency would represent how many cycles can it complete in 1 second. Okay. So you could just flip it. So if you're thinking about if it can do 0.25 is the period, well, that's 1/4. And if I flip that, that means that I can do 4 cycles per second. Also, just think about it hopefully intuitively of if I can do 1 cycle takes 1/4 of a second, well, how many of those would I be able to complete in 1 second? I'd be able to do 1/4, 2/4, 3/4, 4/4. And so therefore my period or my frequency, is 4 cycles per second. All right, let's look at one more problem where I kind of put some of this together. Okay, we're also going to bring back in concavity and points of inflection and all that stuff. All right, so we're just going to do example A. It says first find the 5 key points for 1 period. Remember, my key points that I want to look at are things like max and min and intercepts. So I see 0, 0, pi over 6, 3, pi over 2, -3, 5 pi over 6, 3, and pi 0. Okay, I'm just identifying these key points right here. All right. So if I'm looking at this, it then asks where's the function concave up and concave down. So we've done a lot of concavity, but hopefully you can see right here that these are the pieces that are concave down. And that would be from 0 to pi over 3. And then 2 pi over 3, 2 pi. And then concave up would just be from pi over 3 to 2 pi over 3. All right, identify the intervals where the function is increasing or decreasing. Okay, so if I'm increasing and increasing here, and then I'd be decreasing and decreasing here. So for increase, that would be from 0 to pi over 6, and then from pi over 2 to 5 pi over 6. And then decreasing would be the parts that are blue. So pi over 6 to pi over 2, and then 5 pi over 6 to pi. All right. And then the last one says the points of inflection. Well, let me go back and highlight my concavity pieces. So the green are concave down and the yellow's concave up. Points of inflection are where it switches concavity. So this would be at, I'm just going to label this POI, points of inflection, at pi over 3, 0, and 2 pi over 3, 0. Okay, those are my 2 points of inflection where it switches from concave down to concave up or vice versa. So hopefully that kind of helps solidify, maybe if you were a little unsure about some of the concavity and increase, decrease, that kind of solidifies that from Unit 1. So that wraps up 3.5, is that? Wow, we're moving. 3.5, and I hope you have a great rest of your day.